Hello everyone, my name is Adam Haikal bin Muhammad Rizaldin and joining me today are Fidaus, Ismail and Arisa. Today we'll be presenting on how web browser navigation works using the stack data structure. So yeah, let's begin by introducing the members of our group, starting with Fidaus first.
My name is Muhammad Firdaus bin Muhammad Jafri. Ismail.
My name is Ismail bin Azhar.
My name
Next.
is Noor Arisa Husna binti Anafia.
Okay, let's start with the application we are discussing, the web browser. A browser allows user to navigate website and track visit page. Behind the scene, it uses a data structure to manage this page, helping user go backward or forward during browsing. That data structure is a stack. Okay, next. Here we can see how LIFO, last in first out, works in browser navigation. There are two steps involved. First, the back stack store page you visit. Second, the forward stack store page when you go back. Every time you visit a new page, it push onto the back stack. Going back push the current page to the forward stack. Okay.
Okay. Moving on to the how moving on to the how the application works operations. Now let's look at the operation. Visit page. The browser loads a new page. Then the user click link. It push the current page to the back stack and clears the forward stack. When the user push the back button, it move you to the previous page using the back stack. Uh, when the user press forward button, it move you to the next page using the forward stack. Next reload refreshes the current page without changing stack. All of these are common browsing actions and they are powered by stack behavior. Okay, next, Arisa.
So for slide 6, which is example navigation, A to B to C, let's go through an example. Imagine you visit 3 pages, A, then B, then C. At this point, the back stack has A and B, the current page is C, the forward stack is empty. This shows how the browser remembers the path you've taken. Next. So for slide 7, clicking back to B, now if you click the back button, the browser moves C to the forward stack, B becomes the current page, and back stack now has A. This is how you move back in browsing history thanks to the LIFO behavior of stacks. Next. So for this slide is clicking forward to C. If you now click the forward button, the browser moves back to page C and the forward stack is cleared again. As you can see, these operations are simple, fast and efficient because they rely on stack operations. Next.
Okay, moving on. This is the algorithm efficiency web browser navigation using stack. Here are the algorithm behind those browser buttons. Visit page. Push current to back stack. Clear forward stack. Go back. Pop from back stack. Push current to forward stack. Next. Stack. Push current to back stack. Reload. Refresh current page. All of these are operation one. Time complexity meaning constant time and very efficient. Next. Muhammad Firdaus.
Conclusion on efficiency. So why is this structure great? First, stack operation are very fast, all in constant time. Second, they make browsing simple and efficient. Third, user can move through page without any delay. It's a great real world example of how computer science make everyday tasks smooth. Okay, next.
So yeah, right now we got the program listing. Now let's take a quick look at the program listing that demonstrates on how the stack operation works in the browser. So yeah, Ismail, can you take a look at the next slide that shows another program listing? And yes, so and then back to the previous slide. So you can see functions like visit page, go back, go forward, and reload. What are these functions? So yeah, first of all, alright, let's start from the visit page function. The visit page function, it stimulates stimulates visiting a page. The current page is pushed to the back stack and the forward stack is cleared. This reflects real browsing behavior where going to a new page resets forward history. For the go back functions, this function pops the most recent page from the back stack and pushes the current page into the forward stack. It's like clicking the back button. The browser shows the previous page, the previous page. Like that. For the go forward function, this function pops from the forward stack and pushes the current page into the back stack, just like clicking the forward button. And finally, this one is simple. It refreshes the current page but does not affect either stack, so your navigation state remains the same. All of these are done in a constant time, meaning the browser doesn't slow down no matter on how many pages you visited or how many tabs you have created. This code is a great example of applying data structure knowledge to a real world programming. So yeah, get to the next slide. Yeah, yeah, yeah. This is the summary part. To wrap up our presentation, let's go through to the main takeaways. First, web browsers use the stack data structure to implement back and forward navigation. The LIFO principle, or sometimes known as last in, first out principle, is ideal for tracking page history. You always return to the last page you visited. These operations are incredibly efficient. They run in constant time, meaning fast user response even you browse dozens of pages or tabs. What's amazing is that something so simple, a stack, powers something we use every day without even realizing it. This also explain and this proves on how fundamental computer science concepts like data structures are not just academic, but extremely practical. And to end this presentation, thank you again for watching our presentation. And we hope this gave you a better understanding on how stat logic makes browsing so smooth and stable. And this is all from us right now. Thank you again.
Thank you.
Thank you.
Thank you.